Okay, so today we're going to have a look at the voltmeter and then have a look at the difference between a voltmeter and a scope. And the scope we're going to use today is the picoscope. So, first of all, we're just going to take a quick look here at how to set this up. Now, if you see on the screen here, we have two icons here for picoscope. The picoscope 6 is the one we're going to use, not the diagnostic one. So, if I double click on it here, well, before we even do that, let's take a look. This here is our main unit, our box. So the software is downloaded onto the computer and it connects to the box. And what the box is really is a fancy voltmeter, really refined voltmeter. So when we go to start up, it's connected by USB here into the computer through the cable here. So when we go to start up, then we double click on the picoscope icon and it will fire up for us. So, what we see on the left-hand side here is the voltage scale. It goes from 0 here in the middle up to 20 volts, it's just where it's set at the minute, and 0 down to minus 20 volts down here. And what we see along here is the time base. And you see at the minute up here, if we look, we see the time base up here, if you can zoom in. At the minute it's set to 20 milliseconds division, which means each one of these squares that we can see in here as I go across is 20 milliseconds, giving us a total here of 100, 120, 140, 160, 180, 200 milliseconds. Voltage is adjustable here as well, so if we click in on it, sorry, wrong one, we'll have to use the mouse for this. We can see here we can turn it to auto voltage. We can also, now straight away, you'll notice it's picking up here on the electricity around us, right? So it's set that low now that it's going to pick up anything around us, electricity in the air. So we can set it all the way up on the scale we've set it to at the minute is plus or minus 20 volts. And you can see the larger that I go up in the scale, the less I'm going to see here across the line. So let's just do a quick check here of a battery we have here using our voltmeter. And we connect up, remember, in parallel to check voltage. So correct polarity, black to where the negative is, red to where the positive is. And I'll just well, this is just in case you can't see it. And in this battery, as it stands, is 11.57 volts. Right? So the voltmeter is fine for measuring voltage on something that's pretty static, that's not changing around. We'll do the same on the picoscope here, so connect our negative on, and we'll see straight away it's gone up to just below 12 volts now. So more or less the same reading as the voltmeter. Now, it is a very sensitive tool, as I'll show you here. With these two leads in my hand, as it stands at the minute, we can see 0 volts there. If I hold this probe close to the computer here, you can see it's picking up without actually probing into it. It's picking up on the voltage, the AC voltage running through the actual computer here. If I go, I'm going to pick up my pulse. A little bit, 20 volts. We downsize the battery voltage, you see 10 volts. I'm going to pick up my pulse. Pick it up a little bit. We go down a little bit further. Down to 5 volts. Now it's certainly picking them up. And remember, really what it's used for is picking up pulses of electricity. So, like picking up my pulse here now, just pressed against the jugular. What we really use it for is fast changing voltage signals connected to anything, which is when we're doing diagnostics and we're going to check sensors or ignition signals, it's changing that fast and a voltmeter just isn't quick enough to pick it up, so it won't give us any sort of correct reading on it. The oscilloscope is the best way of doing this stuff, and we also get a visual picture of what's going on. So with the scope itself here, if you can see on it here, down the bottom here, we can run it, we can also stop it, we can flick back through the frames up here. So at the minute it's set up to pick up 32 frames, so it will be 32 of 200 milliseconds picking up at the minute, and we can flick back through the frames and find out what we want to see and zoom in on it. There's also, up in this corner here, we see that we can make the display bigger, smaller, or we can grab a hold of it with this one and zoom right in on a particular section if you really want to get that close to it and have a good look at it. Okay. So, it's quite an easy scope to use. Now you can see up on the top here, menus for doing all sorts of stuff up here. But for the minute, we're not going to use those menus, we're just going to use it as a basic scope. So when we use it as a basic scope, we're in full control of what the voltage settings are. Now at the minute it's set to 5 volts, so if we look at the divisions all the way up here, each division is 1 volt, and the same going down, each division is 1 volt. But we're in control of what the voltage is set to, so we set it back to 20, and what the time is set to. So if I'm clicking on the time one, you can see the menu comes up, milliseconds, seconds, division. So we need to control the voltage and the time, which means we will have to have an idea of how quickly the signal is changing. Now we can mess around with it a little bit if we don't see what we need to see. It's a bit like a magnifying glass, so if I'm too far away from it, it can't see me. If I'm too close to you, you still can't see it. So we have to control the distance we're looking at the electrical signal from, and we have to have an idea of how much electricity is there in voltage, right? So whether it's up to 20 volts, whether it's millivolts we're looking at, but we're in full control of it. And that way, the theory is needed here now for all these sensors and ignition stuff we're going to look at, just so as we can get an idea of where we are voltage and time-wise, so we can set the scope up. Once I set it up, remember, you cannot really do any damage with a scope. We have 2 leads here, and we see on the box here, this is a 4-channel scope. So each channel is coloured, so we have a coloured lead associated to it, and whatever the colour is, so if it's blue here, we use a blue lead, which gives us a blue line. If we go on to the next channel, it's a red, we use a red lead, and we get up a red line and signal from it. Same with the third one, which is green, and the fourth one, which is yellow. So it's quite an easy tool, a logical tool to use. 2 leads on it here, and for practically all applications that we'll be using it for, 1 lead, excuse me, 1 lead goes to earth, the other lead is what we're going to probe in. So for the vast majority of stuff on a car, you'll be back probing. So this very thin needle here is going to press down between the moisture stop and the wire and pick up off the wire. Now for some of the engines we have here, they've built on breakout wires for us, just so because so many people will be probing them over the years that they don't want the insulation and wiring harness damage any goods. We can use the breakouts on it just to make it a little bit easier for us. Okay, so again, same thing. As the voltmeter. And we can see, right, if the signal was changing very rapidly here, and we're just tapping this off the battery here, simulating the signal on and off, it's going to pick it up for us. So it's picked it up there. We're going to stop it here. We're going to go back through the frames. Up here on the top, we can click back through till we find one of them. Now, again, we can see if we zone in on this one here, we want to take a look at what's going on here. I can come up here, I grab the magnifier, and I can grab it around here, pull it in, and it will enlarge that section from it. So we still have the original display down here, but this is what we've zoomed in on here. And we can see it varying from 11.61, and we can use, there's little grid lines here that we can use, right? So if I wanted to say what was, I'll grab this one, I'll bring it down here, just rest it on top of that line, that's where we started, 11.53. I'll grab the next one here, and we're going to bring it down just to the bottom, to where it bottoms out here before it drops off altogether. And we can see it drops up this box for me here. So it's telling me where I pulled the first line down to is 11.53 volts. Where the voltage dropped down to was at 8.25 volts, and the difference, the delta in between them, is 3.259 volts. We can also use the side ones here to pull them out if I wanted to see how quickly I did that from. So let's see, from where I dropped it off there, I can use the next one here and pull it out and just see where it goes back up to the 11.97 volts. So there we are there on this one. The difference between them, between those two lines where I dropped off originally and where it came back up here, gives me a delta of 624.2 macroseconds. So a pretty quick count. So we can use these lines when we're using, if we wanted to say, look for dwell time on an ignition system or a pulse width on a signal coming from a sensor, and seeing how quickly it was being produced, what sort of voltage levels then we have on it, difference between voltage on and voltage off. And if we want to get rid of the whole lot then, we just come up to this box at the top up here, and we can close that off, and that'll get rid of all the lines from it. And again, if we want to see the full complete waveform again, I'll just close off this little box down here, and we're back to our original waveform. So, very easy tool to use, and it's a must really in all garages now at the minute, because if you get a fault code and it's sending you towards a crankshaft sensor or a camshaft sensor, whatever it is, remember the diagnostic tool is only pointing you in a direction, telling you there's something wrong here. It's not telling you the camshaft sensor or the crankshaft sensor is faulty, it's just telling you there's something wrong here. What we use the oscilloscope for is zoning in and testing that sensor now, right? So if it's an inductive type sensor, which we spoke about there during the week and last week, it's normally a 2-wire sensor, normally. Now there are some newer type Hall type sensors which are 2-wire as well, but for our purposes at the minute, a 2-wire sensor will nearly always be an inductive type sensor. And remember, an inductive type sensor creates its own voltage, back to Faraday's principle of a magnetic field, coil of wire around it, and some sort of relevant motor, so something passing it by, disrupting the magnetic field and giving us a sine wave. If it is a Hall sensor, like we had a look at on the distributors, remember it's a 3-wire sensor. First wire will probably be a positive. The third wire will probably be a negative. So we confirm we have a positive and we confirm we have a negative. The middle wire then is going to be our signal wire from the sensor out. So we could use a voltmeter to confirm positive and negative, but because the signal is going to change that quickly, we'd have to use an oscilloscope to see if it's actually changing first. Now, old school way of doing this was we used to use an old 5-volt LED, right, and plug it into the sensor wire, and we'd have to cover the sensor wire up so it was really dark around it, because it's going to LED would flick on and off really quickly. So we really have to look at it and see, was it actually glimmering on and off for us? And because it's doing it so fast, sometimes it's very hard to see it actually switching on and off. Whereas using an oscilloscope gives us a really, really easy way of looking at it here. We get a visual description of it, we can stop it, we can freeze it, we can go back and take a look at exactly what's happening with that on-off signal. Is it good, is it bad, is there a disruption in it like this here at the end of this one? What's going on with it? So again, the scope itself is an invaluable tool when we're doing diagnostics on cars. Okay, so that's going to be it for this video, and we'll take a look at some actual workings of ignition systems in the next video. Okay, that's it for now. Thanks.